Right now, Europe is enduring a relentless heat wave, pushing the mercury past 40 degrees and forcing countries like the Netherlands to issue historic code red alerts. The heat is immediately visible on the streets. Emergency services are stretched to their limits, major outdoor events are being canceled, and residents are crowding into public fountains just to find a moment of relief. A typical heat wave starts with a standard weather pattern: clear skies, high-pressure systems, or parched soil. But climate change is now loading the dice, raising the baseline so that when these patterns arrive, the heat climbs higher and stays longer than ever before. This graph shows how our daily temperature cycles are breaking down. Notice how the nighttime temperature troughs are rising higher over time. The overnight lows refuse to drop, meaning our bodies, our plants, and our power grids get zero reprieve. Without that crucial overnight cooldown, the heat days of uncomfortable weather compounds into a lethal disaster that pushes the most vulnerable populations to the absolute limit. For many of us in the West, the immediate reflex to a spike in temperature is to go inside, shut the windows, and crank up a fan or the air conditioning. But that assumes you have the money to run them. Many vulnerable groups, particularly the elderly living on fixed incomes, are forced to sit in dangerously hot apartments because electricity is simply too expensive to leave those devices running all the time. This flowchart illustrates the core problem with mechanical cooling. An air conditioner pumps cold air into a closed space, but requires massive amounts of energy, venting disproportionate waste heat and refrigerants back into the atmosphere. Sticking a wall of window units on the side of a brick apartment building doesn't solve the underlying issue. Dense urban infrastructure naturally absorbs and traps the sun's energy. We cannot air condition our way out of this crisis. Relying on individual cooling machines is a luxury that leaves the poor behind, while actively accelerating the very planetary heating we are trying to escape. While Europe scrambles to adapt, communities across Asia and Africa have endured dangerous heat exposure for decades, experiencing roughly 500,000 heat-related deaths annually. This pie chart illustrates global cooling access. In most South Asian countries, barely 5% of households have air conditioning, relying entirely on the natural environment. This creates a stark divide. A wealthy few move between air-conditioned spaces, while informal workers endure crushing heat outdoors. And extreme heat rarely acts alone. This visualization demonstrates the relationship between temperature and evaporation. With every 1 degree Celsius rise in temperature, there is a 7% increase in water vapor in the atmosphere. The heat aggressively pulls moisture straight out of the earth. As a result, entire ecosystems and critical water bodies are completely drying out, destroying local agriculture and surrounding natural habitats. For the 2.2 billion people who already lack reliable access to clean drinking water, securing daily hydration becomes an incredibly manual, physically exhausting task where communities must queue up and ration every single drop. When mechanical cooling isn't an option, an extreme heat event instantly transforms into a severe, widespread dehydration and survival crisis. Where electrical cooling is out of reach, communities rely on passive techniques, structural adjustments designed to reject heat without a power source. One of the simplest architectural interventions is right above our heads. Applying specialized, highly reflective paint to the rooftops of homes and schools bounces solar radiation back into the sky, drastically lowering the temperature inside. It also requires restructuring our built environment to capture natural airflow. We have to intentionally break up the dense blocks of concrete and asphalt that hoard heat in the middle of our cities. This is where nature-based solutions are highly effective. Planting dense tree canopies directly neutralizes the urban heat island effect, providing a physical shield from the sun while naturally cooling the surrounding air. Beyond physical infrastructure, survival relies heavily on bottom-up planning. Early warning systems only save lives if they are issued by sources the public actually trusts, directing people to community shelters where they feel welcome. Passive cooling proves that surviving a warming world requires adapting our environments to work with the climate, rather than trying to overpower it with machines. Back in the wealthy cities of the global north, local authorities are racing to adapt. They're opening air-conditioned public buildings to serve as temporary shelters and urging people to check on their elderly neighbors. These acute emergency measures provide life-saving relief in the moment, yet they remain temporary interventions for a crisis that is becoming the new normal. Climate policy experts warn that while we must learn practical strategies from the global south, we cannot romanticize their forced, enduring exposure to dangerous heat. The temperatures we are facing now are unlike anything humanity has dealt with in the past. What is actually required is durable adaptation. We need a massive, whole-of-government investment across multiple sectors to retrofit our existing housing and completely rethink how we design our neighborhoods. We have to turn our heat-trapping concrete grids into dynamic, self-cooling ecosystems that naturally protect the people living inside them. Surviving this new baseline requires a move away from individual mechanical units toward a total structural transformation of our urban landscapes.